Imagine a busy restaurant kitchen, constantly preparing dishes. What happens if a cook suddenly spills a tray of food? If each cook remembers every single order, then a spill means chaos and lost information. But what if each new order is given fresh to any available cook, with no memory of past steps? This shift in approach is very much like the difference between stateful and stateless server architectures, especially when it comes to bouncing back from issues. Yes, a stateless server generally improves error recovery significantly compared to a stateful one. Its fundamental design allows for a much more resilient and agile response to failures, making systems more robust and reliable. The core mechanism behind this improved error recovery lies in the server's lack of persistent session data. In a stateless architecture, each request from a client contains all the necessary information for the server to process it independently. The server does not store any client-specific context or session state between requests. This means if one server instance fails, any other available server can immediately pick up new incoming requests without any loss of ongoing transactions or user data. This architectural choice fundamentally prevents cascading failures tied to a single server's internal state. To leverage this characteristic for better recovery, engineers typically deploy multiple identical stateless server instances behind a load balancer. If an individual server encounters an error or becomes unresponsive, the load balancer can automatically redirect subsequent requests to a healthy instance. The client does not even realize a different server is handling their request, ensuring seamless continuity. This approach also simplifies scaling, as new servers can be added or removed without impacting existing client sessions. A key concept here is idempotency for critical operations, where performing the same request multiple times has the same effect as performing it once. While not strictly required for statelessness, designing for idempotency in client requests allows for safe retries after a server failure. Another advantage is the ease of horizontal scaling. Adding more stateless servers is straightforward because there is no complex state to synchronize, which directly translates to improved fault tolerance under heavy load or during unexpected outages. Ultimately, the strength of a stateless server in error recovery comes from its inherent disposability and interchangeability. Because no individual server holds unique, essential data, any instance can be removed, replaced, or restarted without disrupting the overall service. This design philosophy fosters systems that are not only easier to maintain but also remarkably quick to recover from unforeseen problems, ensuring a consistently smooth experience for users.
If this helps you code smarter, like, subscribe, and stay tuned for more.